Evening, everybody. I am, as usual, having technical difficulties tonight. It's a wonderful variety. So every night it seems to be a little bit different. Tonight I have my primary control computer is moving at about 10% of its normal speed all of a sudden. I don't understand why. Not sure what is happening, but it is definitely moving very, 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 very slow. And so I am struggling right now trying to get things straightened out here. I'm not sure if Windows is trying to update or something. I probably should have checked that before coming in tonight. Usually I do that kind of thing. But anyway, let me now I'm going to try and restart my SharpCap image capture software to see if it will start normally this time, because it was having problems earlier. For some reason it would not allow me to complete the capturing of flats process. I don't know what was going on there, but when I captured my flats, everything seemed to go normally until the very end, and then all of a sudden it just hung. It just wouldn't go anywhere or do anything for like 10 minutes. So I had to kill the whole thing, and now I am trying to restart it again, but again it's taking about 5 times longer than normal, and I have no clue why, but my computer is definitely struggling for some reason tonight. Alright, let's see if we can load a camera here. Come on, come on. Cameras. And now it's not recognizing my camera. Okay, cameras, rescan for cameras. And it found it, good. Okay. I will, let's get the test pattern away here, so you can actually see what I'm doing here. It's currently loading the camera. I need to get this plugged in. Done. Okay. Yeah, see, it's coming up and not responding and not responding, and for some reason this computer is really, really struggling tonight, and it's usually pretty rock solid, so I'm not really sure why this is happening. But, like I said, it could be some sort of Windows background process that is occurring. Alright, let me get the proper profile loaded for this camera so we can actually see stuff. Yeah, Frank, I did. I tried that earlier before I connected, and CPU was only about 15 or 20%. Disk was maxed, and I think something in the flats capture process was just maxing the disk, and I'm not sure why. But yeah, so it's a bit of a mystery. Okay, so we got that. So now I need to go get my flat. So again, everything is just responding really, really slowly. This machine is usually bulletproof, so there is something going on tonight. Yep, see, still waiting, still waiting, still waiting. Nothing to do but wait. Captures. And we're going to be tonight, 3, 4, flats. Well, thankfully, at least it caught the flat. Come on. Thankfully, at least it caught the flat. So now it needs to actually load it. It's still there. We go. Okay. So that's now in. We have all that stuff loaded. All right. Gain is right. Okay. Come on. Now getting this to respond. All right. Well, tonight we are going to be doing the Cloudy Nights March Observers Challenge that was put up by our friend Ollie over in Germany. And so let's see how long this takes to load. Just everything moving at a crawl tonight. Sometimes computer use is a Zen experience. It takes whatever time it takes. Just everything is just taking 3 to 4 times longer than normal. All right, the observing challenge. Now we wait for this page to load. Okay, so the easy ones. M67 is the first one. All right, so nope, not that one. That one. M67, so in our Stellarium, we will hit F3 and boy, everything is just moving really, really slow. This is kind of crazy. Okay. And now Stellarium is not responding. Wow. Huh. Yep. Everything is just going to be a Zen experience tonight. It's just going to be really, really slow. It's kind of a pretty cluster. Alright, so M67. And let's see, I didn't set up my script, so let's go to next target 183. And it will change the settings here. Alright, and looks like my internet is also doing its up and downy thing a little bit, so tonight may just be a complete adventure. There you go. Alright, let's move this a little bit more into the center. Oh good, this is responding somewhat normally. That's a good sign. Okay. Oh, that took a while to show up. But at least it ran okay. Alright, well, let's try starting to do some imaging. 60 seconds is usually a bit too much for star cluster, but we'll see what we can see. Alright, that finished. This can go away. This can go away. And then, well, we will see what we get here. That can go away. And we'll let this load for about 60 seconds. Okay, Guy, am I back? I'm seeing everything responding normally at my end. Are you guys seeing okay out there? Everything at my end seems to be normal, for the moment at least. So let me know in chat if you can't hear or see me. Meantime, I'm going to assume that you can. Alright, M67. Nice little star cluster there. Let's see what Wikipedia has to say. Okay, thanks, Frank. Good for the confirmation. Okay, Guy, you may want to refresh your page because it's good everywhere else. So just do a refresh on... Well, I'm not sure what you're getting there, Guy, because everything seems fine at my end here, and Frank seems to be seeing normal things, so... let's see what... M67. It's an open cluster in the equatorial half of Cancer, discovered by Jonathan Gottfried Kohler in 1779. Estimates of its age are between 3.2 and 5 billion years. Wow. That's definitely some old stuff. That's about the age of our solar system. Distance estimates are likewise varied in typically 8 to 900 parsecs, or about 2,500 to 3,000 light years. It is not the oldest known cluster, but clusters known to be older tied to the Milky Way are few, and none of those is closer. It's a paradigm study in stellar evolution. It is well populated. It has negligible amounts of dust obscuration. All its stars are at the same distance and age, save for approximately 30 anomalous blue stragglers, being, however, generally products of mass transfer in binaries or other constellations. It's one of the most studied open clusters, yet estimates of its physical parameters, such as age, mass, and number of stars, of a given type vary substantially. It has more than 100 stars similar to the Sun. Well, from its age, that sounds about right, because our Sun is probably about 5 billion years old right now. So, let me turn the background music back on here. There we go. But it's one of the oldest and closest clusters. Or I guess closest old clusters that are in the sky. So, that's kind of neat. Yeah. Getting a little bit of a... the stars are a little streaked here. In fact, I might clear this and start the live stack over again. Because the camera, the scope may have still been moving a little bit when it captured the first capture. That looks a lot better. So we'll see. We'll stack a couple of these images and see how it... Oh, cool. Glad to hear it, Guy. Just refreshed. For some reason, your video got stuck at your end. Good to hear. Yeah, there we go. Now we've got a couple of stacked subs on there, and it looks like the stars are staying nice and round, so I think that's what happened. I think the scope hadn't quite settled when I took the first image there previously. Let's make sure we're all good here. Internet is still doing its bouncing around thing, but yeah, in fact it looks like now that it just went down and went away. Huh. it seems to be... the internet is still doing its kind of weird thing. It seems to be okay, and then it crashes, and my upload speeds seem to be highly variable. So, hopefully I'm going to continue to come through. This happened on Tuesday night as well, and it basically just resulted in skips. In the audio, it would skip, and I guess you guys are probably experiencing a little buffering at your end. For some reason, my upload bandwidth is, let's see, like right now it's fine, but then it spends a few seconds diving, so I don't know. It seems to be a little weird. I may have to call my ISP tomorrow and find out if there's something wonky going on. But this is M67, so it's one of the closest old clusters to us. Possibly even as old as our own solar system, with about 100 stars in it that are just like our sun, kind of main sequence sort of stars. So, okay, let's see what the next, see what Ollie gave us. M106. Let's try, where are we? M106. F3. Let's see. Here. Let's center on that. And then we'll go M106. Boink. Oh yeah, not too far away. Right under the Big Dipper. There's a lot of galaxies out in here. So this will be a fun one to do. So, let's go check out M106. Next target 183. Alright. And go to M106. Luckily, things seem to be responding normally right now. Again, the internet seems to be down, but hopefully you guys are still able to see and hear me okay. Possibly a little buffering at your end. Okay, and there it is right there in the view. So let's center it up. And I'm also getting this error message too lately, and not really sure what's going on there. Everything seems to continue working normally. This happened on Tuesday night as well, where I started getting this cryptic error message when I'm trying to move the mount. So, not real sure what that's about, but the developer had me send the logs, so hopefully he's checking it out. Okay, it's just about drifted into our view. Let's try and stabilize it here. Yeah, that looks pretty good. Okay, so M106. Let's start the imaging on that. And while that's loading, I will look this one up and see what... Okay. Okay, M106 is an intermediate spiral galaxy in Canis Venatici. It was in 1781. It's at a distance of about 22 to 25 million light years away from Earth, which is not too far in galactic terms. Actually, probably considered one of our more local ones. It contains an active nucleus classified as a Type II Seyfert, and the presence of a central supermassive black hole has been demonstrated by radio wavelengths. Ooh, wow, and you can see there's a number of other ones in here too, so this will be another one of those how many galaxies can we find kind of deals. Let's get the histogram adjusted properly here. And we can see we're definitely going to have some definitely have a few galaxies in the image. So gonna be pretty cool. I'm gonna go put the light shroud on the end of the scope real quick here. I should probably wait until I go to the next object to do that, because it'll mess up the capture if I do it now. Just had a bunch of traffic drive around here, so this exposure may be drowned out. I have to see what comes in on this. Let's see what it does with this. This one might not be a very good one. Let's see what happens here. This may be just blasted out with light. No? Okay. It seems to be okay. Good. Alright. We'll just leave it as is. M106. So there's a supermassive black hole in the center of this with a highly active nucleus. It contains an active nucleus classified as a Type 2 Seyfert and the presence of a central supermassive black hole. Has been demonstrated from radio wavelength observations of the rotation of a disk of molecular gas orbiting within the inner light year around the black hole. NGC 4217 is a possible companion galaxy of M106. 4217 is a possible companion, so this one right up here, so we might not be able to see that because it looks like it's right above the plane. And so that one, if that one is that one, no, because it can't be. I think, yeah, no, that can't be it either, because it's above the plane. It's above the plane of the disk. It's perpendicular to the plane of the. So it's got to be up here somewhere, probably just out of our reach. But we definitely have other galaxies that are in here. Satellite moving through, which we may or may not capture in this sub-exposure. We'll have to see if a streak shows up when this sub-exposure comes in. Nope, doesn't look it. Everything just got darker. No streaks. That's okay. But there's definitely a lot of other little galaxies around here. Actually, it looks like there's a little fuzzy one in there. Definitely one there. Looks like a couple here. There's a sharp, that you can see the sharpness of the star there. This one here is definitely sharper, and this is definitely a fuzzball, which means galaxy. This one here looks like a little bit of a disk, or possibly a barred spiral itself. A little bit of a puff of light there that's unclear. Definitely a spiral here. And then we got this bright one up here, which is along the disk itself. Well, let's look at, let's remove my filters, which will allow, no, you stay, you go, which will allow more stuff to come in, and we can see. Yeah, see, there's a galaxy right in, actually there's one sort of underneath it. That's kind of interesting. two galaxies kind of overlaid. 4248 is just above it, so that I think is this here. And then these two, I believe, are these two, maybe? Perhaps? Hard to tell. With the way my scope is oriented, it's the scope is on its side at the moment, so. Hey Pete, good to see you. Thanks for being here. Hi Jeff. Following along on Stellarium, huh? Cool. Yeah, so kind of same game as Tuesday night. My internet is sort of, my upload speeds are just going from full strength to half strength to 0 to half strength to full strength to kind of all over the map again. So apologize for any buffering you guys are seeing or herky-jerkiness in the images or my audio, but I think I'm going to have to call my ISP and find out if there's just something going on with the signal coming out here. Because out here in the middle of the desert, we don't have cable or anything. We don't have fiber optic or anything. It's all microwave transmitted through dishes, and it works really well mostly. But this week has been kind of all over the map. So anyway, 'tis what it is. Surprised to be paid for all these nice dark skies out here. And technology is a bit more limited. But M106 is coming in kind of nicely here. Getting a nice disc and some nice features in the arms showing up here. Some little clouds of possible star formation or something that are in some of these outer sections. So you think, yeah, so yes, if this one here I think is here, which makes sense because my scope is pretty much directly on its side right now, with the way it's oriented. And in fact, I should do that. Let me go to my desktop and bring up my setup here, because I should show my setup and what I'm using. Normally do that at when I'm starting up, but come on. Okay, now this isn't responding. Whoa! Okay, I don't know what happened there. Just weird computer issues tonight. Come on. Just endless hourglassing, things running really, really slowly. And all I'm trying to do is magnify this, and it won't. There we go. Okay, yay. Come on. So here is the scope I'm using. I'm using a 6-inch f4 imaging Newtonian. It's a simple reflector telescope with basically a full-size mirror in the back and a diagonal mirror right here that bounces the light up into the eyepiece, or in my case the camera, which is mounted up here. And it's all riding on a Celestron Evolution mount that is on my new/used Celestron HD Wedge that I have on my same old spare no expense cinder block pier. But I decided to upgrade to from my homemade wooden wedge to this one because the homemade wooden wedge wasn't really wasn't really designed for this. It was designed for a much smaller scope. So I decided to put it on this to give it a little more rigidity. However, when the scope is swung all the way around and pointed off in this direction up here, the scope is basically on its side. And so that's why this is at 3 o'clock in this image and at noon in Stellarium, just because of the orientation of the telescope makes everything twist around to the side. Frank asked if I've gotten better results with the Celestron Wedge over the homemade one. I've only used it a couple of times. This is actually only my second time using it. So far, it seems like my stars are a little bit rounder, perhaps. One of the other reasons why I did the upgrade too was that the wood, while I had created that wooden wedge, I never finished it. So being out in the elements, basically being out in the sun, because we really haven't gotten any rain hardly at all this year, it was starting to degrade the wood a little bit too. So it was either put some work into finishing it and getting it coated and treated, or just upgrading to a bigger, better mount, and that's what I chose to do. So still early days. I think the stars are looking pretty darn round with this, whereas sometimes I got streaky stars with the other one. These, I think, are holding their shape really well, so I think it is a little bit stronger. Well, I know it's certainly bigger and stronger than what I had out here before. But it was a question for me as to whether what was causing the streakiness was the wedge or the mount itself, just the limitations in the evolution mount itself. So I don't know. We'll see. Jury is still out. But here's one M106 starting to fill in nicely. Got a nice big disk here. Supposedly a super massive black hole in the center of this galaxy. So that's kind of cool. Let's see what else we got next. Okay, so M108 surfboard. Alright, let's see M108. And there's just a lot of... oh shoot, no wonder there's a lot of galaxies. This is why I keep my filters turned on, because if these red circles are all galaxies. So if I don't keep them filtered out, there are literally billions and billions of galaxies out there. And I don't even have all the catalogs loaded in Stellarium. So I have to keep these on so that I limit what I'm seeing to only what makes sense for my little scope. And even at that, there's quite a lot of galaxies around. So, oh, and now not responding. Okay, let's go to M108. Just up inside the Big Dipper. So basically, that's the Big Dipper right here, the handle and the bucket. And so right now, M106 is underneath, and M108 we're going to move right up into, almost touching the Ursa Major itself, and go right up in there, and go to M108. So, oh, there we go. Now we got photobombed. There's a satellite for you. But M106, and she purty. In fact, I could even clean that up a little bit more. Oh, and another thing I forgot to do. I forgot to do this at first on Tuesday night too. I forgot to put my enhancements on here, which also really help sharpen things up quite a bit. But she is a nice looking galaxy. No doubt about that. Nice disk. Nice disk in there. And quite a few other galaxies around. In fact, we're coming into galaxy season because this part of the sky between Ursa Major and Leo, and once again Stellarium is not responding. Come on, come back. Between Ursa Major and Leo, there's a bunch of galaxies and a whole string of galaxies that'll be coming up. So over the next couple of months, 2 or 3 months, it's called galaxy season because all of these get higher and higher in the sky every month. And so it's a very galaxy-rich time of the year. So we're coming into that. Okay. Thank you, M106. Let's move on to 108. Alright. Boink. And zips around. Oh yeah, you can see it right here. So let's go ahead and move that over into here. Yep, I know. You like complaining. I'm not sure what you are complaining about, but the developer is looking into it. I had to send him the log so he could get a detailed give a detailed analysis of whatever is going on with it. Hopefully the logs will tell him what he needs to know, because kind of annoying to have that thing continue popping up. Folks seem to bash wedges an awful lot, Frank says. Yes, and actually, honestly, for good reason. Wedges are... they just, like, triple the complexity of setting up your gear. They do make... they allow you to be equatorially aligned. However, come on, stabilize. I'm trying to get this to stop moving. They allow you to be equatorially aligned, but they are much more complicated to set up. Sorry, imaging. So they're very much a mixed bag. They're big and unwieldy, and they put everything at awkward angles and throw things off balance, and so they're kind of a pain to deal with if you set them up every night. So I can appreciate why people bash them. If you're going to do this kind of thing, you're better off just going with an equatorial mount entirely, like a GEM or something, and stay away from having an AltAz mount mounted on this thing. What makes it work really well for me, and what makes wedges really worth it for me, is being able to leave the wedge outside permanently. So it's always permanently polar aligned on the pier, and that makes the process of setup really, really simple. The mount and the scope and everything else go inside, but this stuff stays out here, and there's nothing weather sensitive in this. I cover it with, you know, white coverings or something to keep it cool in the sun or keep it protected from the elements, rain and whatnot, but it can sit outside very easily. And when you can leave the wedge set up outside polar aligned, then it's a simple matter of bolting the mount onto it and putting the scope on it and do a quick alignment, and you're done, and you don't have to worry about polar alignment because it's already polar aligned and stays outside. So I can appreciate why people don't like them if they're trying to set them up every night. They are much more difficult. But if you can leave it set up outside, it's a great advantage, because it gives you the benefit of being equatorially mounted while having a fast, easy setup of a regular AltAz mount that isn't equatorially aligned. So it's a mixed bag, but I really do like it. If I was not able to leave mine set up outside all the time, I probably would not be using it. I probably would just sell everything and just get into a German equatorial mount, an AVX or a EQ6R, or something where it's just the mount itself is all polar aligned and things. But for me, leaving that kind of thing outside, anything with electronics or lubricants in it, which any mount which any mount has, I can't leave it outside, because summer days out here hit 115, 120 degrees, and that electronics and greases and other lubricants do not like that. In fact, most plastics don't like it either, so I just can't leave a mount outside year-round. And so, but the wedge is just fine. The wedge is just metal. This is just a hunk of metal, basically, a highly machined precision metal, and so it's fine being outside. Just throw a plastic bucket over it, or a white canvas bag or something, and it'll be fine. but the mount itself that has electronics and lubricants and all sorts of things in it, that will not do very well. So, yeah, that's exactly right, Jim. I'm leaving a wedge permanently set up is the way to go. If you have to set up every night, just go with an AVX or go with some other equatorial type mount. So here is M108. M108 is a barred spiral galaxy. Oh, cool. Well, hopefully we'll be able to resolve some of the bar here. What that means is there should be, coming off either side, there should be a dense portion of basically stars where that have formed sort of a bar shape around the core of the galaxy. Although the problem we have is that we're not looking very much at the plane of the. We're kind of looking at the edge, not the plane, and so it's a little bit harder to see when we're kind of looking at it sort of edge on. Again, this was also discovered by Pierre Machin in 1781 or 82. Yeah, from any perspective from the Milky Way, this galaxy is seen almost edge-on. This galaxy is an isolated member of the Ursa Major cluster of galaxies in the local supercluster. And so that's kind of what I was showing you earlier in this area. There's just a whole bunch of galaxies in here around Ursa Major. The Big Dipper has a whole bunch of stuff, especially underneath it, again, toward Leo, where there's just a bunch of stuff going on in there. It has a morphological classification of SBBC, which means it is a barred spiral galaxy with somewhat loosely wound arms. The maximum angular size of the galaxy is about 11 arc minutes by 4.5 arc minutes, and it's inclined 75 degrees to the line of sight. So it's only 15 degrees from being edge-on perfectly. It has an estimated mass of 125 billion solar masses and bears about 290 globular clusters. Examination of the distribution of neutral hydrogen in this galaxy shows discrete shells of expanding gas known as H1 supershells. These may be driven by currents of dark matter, dust and gas, contributing to large star formation, having caused supernova explosions. Alternatively, they may result from an infall from the intergalactic medium or arise from radio jets. They have found 83 X-ray sources in it, including a source at the nucleus. The brightest of these is consistent with an intermediate mass black hole accreting matter. Do they actually say how far away it is? I didn't see them say how far away it is. Maximum size. It says what the size is, but it doesn't say where. Redshift distance. 14.1 million parsecs. Let's see if we can't clean this up a little bit. I want to check my focus too here real quick as soon as we get done with this one. Make sure that we're still in focus. I'm seeing there's a lot of splitting in the diffraction spikes here, which usually indicates that the focus is out, and everything seems a little bit fuzzy right now. So I want to check my focus. So in fact, I think I'm going to do that. We'll come back to this. Next target, and a nice thing about being near Ursa Major is Let's make sure I am. Did I synchronize? I did not. Okay. Let's synchronize on it. Good. And let's go up to Merak, which is right there. Although Dubé is even brighter. Even betterer. So we'll go up here and check the focus. Yeah. Okay, so I'm going to mute for a second here and put the Batinov mask on there and make sure that we are in focus. There we are. Come here, you. Come into the center. Alright. Okay, that focus actually is pretty darn good, so it looks good. So let's go back to 108. And try just taking 2 or 3 more subs on that. And everything just responded real slowly. For whatever reason. But I guess everything was okay with the focus. So alright, give that a few seconds to come in. Looks like my internet connection is pretty much stabilized, and I'm going to knock on some wood here when I say that. But that seems to be doing better now. Okay, yeah, so we'll let you get a few sub exposures in. Distance of 14.1 million parsecs. Why do they say parsecs? Which is about 46 million light years. So, $46 million light years. So that's not really one of our local dudes. That's getting a little bit further out for a local guy, but still not real far away. But they did talk about pockets of star formation. You can see there are some really bright patches in it that are well outside the core, which are which we're talking about, was probably what they were meant by the discrete shells of expanding gas extending for several kiloparsecs, known as H1 supershells. These may be driven by currents of dark matter, dust, and gas, contributing to large star formation, having caused supernova explosions. But there are definitely, you can see there are definitely some pockets of, some brighter pockets in here that are obviously pretty high energy, whatever they're doing. Actually, quite a bit of texture in this galaxy. Pretty interesting thing to look at. While this is loading, I think I'm going to go get a jacket on. Be right back. Okay, that's warmer. Yeah, this does seem to be sharper than what I had going on before, but obviously it wasn't the focus that was an issue. It may have been I got one sub in it with streaky stars, so these look like they're holding their shape a bit better this time. So, but pretty cool looking galaxy. Kind of reminds me of the Sculptor galaxy, which is one of our more local guys. That's in the low southern sky. It's just a lot bigger. It's but it also has a lot of puffy cloud texture and structure to it. That is pretty cool looking. This kind of reminds me of that, just a much smaller, more distant version of that galaxy. But definitely a lot of pockets of high energy star formation or something going on. If we could see this from the top down and weren't looking at it quite so edge on, it probably would be fascinating to look at. Did they say this was a barred spiral, or was that the last one? Yeah, it's a barred spiral. So they're saying it is a barred spiral in there, and that they think probably this right here, this patch here of brightness, is actually the barred spiral, the bar that's going through the center of the galaxy. And this may actually be a star in our galaxy, and this one, and this one, and this one may actually be stars in our galaxy. So they're very much in the foreground. But the rest of it is bright fuzzy, so sort of these fuzzy patches in here. That's probably the core, the nucleus of the galaxy there. But definitely an interesting thing. M108. 108th item on Charles Messier's list. What, in fact, is so. This is one of the items that he himself did not add. He actually, his list was 103 by the time he was, he died or stopped observing or whatever. And in the ensuing years since then, researchers have looked through his notes and realized that he discovered another several objects, but he had not formally added them to his list. And so objects 104 through 110, this one being 108 and the last one being 106 we just looked at, are among the 7 that were added by researchers after the fact. But this was one of the things that he found that was not a comet, so stop looking at this thing because it's not a comet, and all he was interested in looking at was comets. So he unwittingly created a great list of objects to view in the night sky. So it's because they're some of the biggest and brightest and most interesting objects in the sky that's very popular. The Messier list is a very popular list with amateur astronomers like me who don't have, necessarily big expensive equipment, and so the bigger, brighter, shinier stuff is easier to see. And it also tends to be bigger, so you can just see more detail in it. So but definitely a lot of texture in this galaxy, so it's kind of neat. Let's see what Ollie has for us. Okay. Let's see, NGC 2903. Suddenly my keyboard is not responding. Okay, come on. Okay, and now my computer is not responding. I'm wondering if Windows is trying to update or something. Hey Carl, thanks for being here. Microsoft Windows, the application. Whoa. Whoa, okay, now now it's catching up and doing everything I was trying to do. NGC 2903. I'm wondering if now the Owl Nebula, we did this just last time, so I won't do that again. That's the Planetary Nebula we did last time. This is also called the Surfboard Galaxy. I missed that. That's right. This is the Surfboard Galaxy, I guess, kind of honestly why. Obviously why, I mean. So, NGC 2903. Let's see. NGC 2903. Twink. Okay. Yeah, see, now we're going to move more over toward Leo for this next one. So, that's cool. Thank you, M108. And we got another nice satellite right through the image. But there it is in context with all the background, the foreground stars in this case, because all the stars we see are in our galaxy. Alright, next, target 183. And go back over to our Stellarium, tell the telescope to move. And we're a bit higher in the sky. This one looks like a nice spiral too. Yep, and there it is right there. So let's move it into the frame a little bit better. Yes, thank you for complaining. I know all about it. Whatever you are. You seem to complain, although not be clear as to why you're complaining. Alright, let's move this a little bit more. There we go. And make sure it settles out. Give it a couple of seconds. No, it continues to march to the right. Alright, let's push it back to the left again. Come on, settle out. I'm not sure why this is moving. But it's every single sub that comes in, it's moving, it's moving, it's moving. Why are you moving? It's almost as if the tracking is not functioning right here. Alright, seems to have stabilized. Alright, let's start the imaging. I know that this mount has some backlash. The Evolution is it's a good mount for an AltAz, but I know it has some backlash. So it does take sometimes 15 or 20 seconds to settle. Usually I can overcome the backlash by just moving the mount slightly in the opposite direction to take up the backlash, but sometimes not. NGC 2903. Let's see, NGC 2903. Let's see what Wikipedia has to say about this guy. An isolated barred spiral in the equatorial constellation of Leo, positioned about 1.5 degrees due south of Lambda Leonis. It was discovered by German-born astronomer William Herschel, who catalogued it on November 16th, 1784. He mistook it as a double nebula. Why didn't that frame come in? That was interesting. Why didn't that sub... Come on. Clearing stack, clearing stack. Huh. Was I just seeing things? I thought it just finished a sub-exposure and then didn't do anything, but the log indicates it did not, so okay. I must have imagined it. Well, there you go. He mistook it as a double nebula, as did subsequent observers, and it wasn't until the 19th century that the 3rd Earl of Rosse resolved it into a spiral form. Yeah, and see, this is still, it's still moving. The mount is still moving, which is why we're getting these streaked stars. So I am going to... Maybe it was an FWHM filter thing. See, and again, this is just now SharpCap is not responding. Definitely some very strange computer behavior tonight. Programs just continually hanging. Very, very weird. Guy asked the question, SharpCap, wait, see, yeah, now SharpCap has stopped responding. I may have to crash and restart SharpCap. Close SharpCap. Yep, and I can't do anything. It's just completely locked up. Come on. Well, I'll try bringing up the task manager, but that's probably just going to create something else to wait for. Yeah, it just... I don't know, this has just been a really weird night tonight with the computer. I've never had the computer do this before. I'm not sure what it's doing. The only thing I can guess is that it's trying to do some sort of Windows update in the background, and it's just causing all kinds of problems. Well, now SharpCap seems to have returned and is now responding normally again. For how long? Who knows? And now the task manager comes up 10 minutes later. So now we've got to wait for this to get out of the way. And everything is just hanging and hanging and hanging and go away. And now the task manager is not responding. Yeah, I agree, Frank. It is very strange. I don't know. Come on. Jeez, how long is this going to take? Well, at least I can get it out of the way. So at least we can see the images as they're coming in. The task manager clearly does not want to respond and doesn't want to go away, so... Oh, no, it just went away. Very good. So we'll see how long this lasts. But notice this one has definitely... This one here has definitely got some more pronounced spiral arms, and of course, unlike M108, this one we're also seeing much more dead on, not quite so much edge on. So this one is, oh, we've definitely got another little puff out here. So this one's definitely a purty one. And back to your question, Guy, I didn't forget about you. I said something interesting. Can you clarify all the stars we see are in our galaxy? Yes. Allow me to clarify. When we are looking at a galaxy, these galaxies are very, very far away. They're tens, if not hundreds of millions of light years away. Let's see if I can find... Yes, this field galaxy is located about 30 million light years away from the Milky Way and is a member of the Virgo supercluster. So it's 30 million light years away. Any of the stars we see are in our galaxy, so they are going to be dozens to hundreds to thousands of light years away. In some cases tens of thousands of light years away if they're really big bright stars. But they are all going to be things that are in our galaxy. Galaxies are comprised of stars. And so when we see another galaxy in our image, that's what we're actually seeing, a huge collection of stars. Anytime you see a star in your image, you're seeing a star in your own galaxy. When stars are really far away, tens of millions of light years in this case, then what we see is a whole collection of them called galaxies, but they're much too small to actually be seen as individual stars when they're that far away. So anytime we see stars in our pictures, those are always going to be in our galaxy, because if one of these stars was 30 million light years away, it would be much too far for us to see an individual star. It would be way too small and way too dim. The only thing we can see at that kind of distance is huge collections of stars called galaxies. And so whenever we're doing galaxy hunting, it's always going to be stars that are in our galaxy and that we see in the foreground, in the surrounding image, are basically us looking through the stars in our galaxy to see outside of our galaxy to see what else is out there. In which case that's always other galaxies. Until you get really far away, and then they do with this whole quasar thing and the stuff that's seen at the edges of the known universe and that kind of stuff. But thankfully that's all well beyond my scope, because I don't understand what any of that is anyway. The challenge when you look into galaxies, though, is discerning what is an individual star from our galaxy versus what is a pocket of intense star formation in the galaxy that you're looking at. So, in this case, we've got certainly stars here, and, we've got a bright pocket here. That could be a small star in our galaxy, because it's kind of sharp-ish. It's not really fuzzy. Whereas this pocket here looks much more fuzzy, and is much more likely a pocket of star formation or some other form of high-energy gases, etc., that are in the galaxy itself. And so this really is a pretty one with all the streakiness in it, all the spiral arms gradually spiraling all the way out into these two big arms that reach out long distances. That's pretty cool. Center that a little better. Let's see, so it's 30 million light years away. And it's a barred spiral. So again, they're calling this a barred spiral. So this solid band of light in here, they're actually calling the bar of the spiral, as opposed to a regular spiral galaxy like the Milky Way that doesn't have this concentration, this linear concentration of stars. It's a barred spiral with moderate to tightly wound spiral arms. The bar structure appears stronger in the near-infrared band. The galaxy as a whole is inclined by an angle of 60 degrees to the line of sight from the Earth. So it's actually still not really even fully face-on. 72% of the stellar mass is located in the outer disk of the galaxy, and 20% is found in the bar. The bulge adds 5%, so the bulge being the core of the stellar mass, and its star population is generally older. However, the central 650 parsec radius volume of the core is a strong starburst region. The star formation rate here is a number I don't even understand, and it is being fed by gas inflow along the bar. There is no evidence of an active nucleus. Huh, interesting. So this is all star formation being fed by the bar itself. That's interesting. It's a pretty one, though. Well, technological problems have gotten quieted down a little bit here for a few minutes. Of course, I haven't really tried to do much, so that probably helps. See, but I do notice down in my taskbar in the system tray, I see a notification down here indicating your device needs to restart to install updates. Huh. Well, hopefully that means it's already done what it needs to do, and now it's just waiting for a restart. So, hopefully that should mean performance should return to normal. And lesson learned, I forgot to do something. Tuesday night was my first live stream for this Dark of the Moon time frame here in March. Normally what I do before my first live stream, in a 2-week, because the moon goes dark for 2 weeks and then light for 2 weeks, normally right before my first live stream of a month, I will fire up my control laptop and manually update Windows fully, as much as, just make sure everything is up to date, blah blah blah, so I don't have this exact kind of thing happen that just happened tonight, which is that the stupid Windows decided to update itself while I was trying to do the live stream. which is not good. So, my bad for doing that. My apologies, and I will definitely fully update it before I hold another one. Hey Curtis, how you doing tonight? But there is NGC 2903, so that's a pretty one. Okay, NGC 3180, the little pinwheel. NGC 3180. Yeah, boy, 31. Now everything is responding just normally because Windows has now finished its stupid update. Yeah. Okay, so that's a pretty one. Let's see what the next one is. Next target. Alright. Go. Wow. Oh, the scope is going like almost upside down here. That's pretty interesting. Stuff that's right around the pole is tough. Whoa. Whoa, I might not be able to get... This might actually be too low. Well, I'm seeing stars. Wow, that is kind of going at a... Okay, where am I supposed to be pointing here? Whoops, come on. I'm supposed to be at 50, 60, 70 degrees. Where the heck do you think you are? 70 degrees and 57 altitude. 70 degrees and 57, 30, 40, 50. Yeah, that's about right. The scope looks like it is pointing in completely the wrong direction. Huh. Well, something weird has just gone on here. Where does CPWI think I'm pointed? It thinks I'm pointed east-northeast. Wow. I'm going to go back to my previous object. I don't understand what's going on here. So, let's go back to... No, not you. Come on. This. Let's go back there. That was... Wow. Okay. Well, something has gone really wrong with my alignment. Because the scope is pointed in completely the wrong direction. So I may have to realign the scope. That is just completely weird. Okay, so I'm going to have to realign. I don't... Well, luckily it just takes a couple minutes, so I'm going to put on mute here, and I'm going to have to reset the scope. So, I'll have to go do that. Be right back. start CPWI again and see if I power cycled the mount. Let's see now if we can... Now something definitely went really wrong there. I'm not sure what, but... Okay, star sense. Ready, and go. So we'll give this. Thankfully it takes just a couple of minutes to realign. But that was definitely very bizarre. Somehow the mount and or CPWI lost the alignment. I've had that happen before with the hand controller. When I was using the hand controller, and suddenly the alignment would just get lost and the scope would be doing these crazy things and pointing in crazy directions. But I've never had it happen like this before with CPWI, so kind of weird. So sorry for the intermission. This shouldn't take more than a couple of minutes to fix. Just kind of slew to 4 different points in the sky and take a picture, and hopefully it will be aligned again. Technological problems when you're dealing with a plate failed to solve. Yeah. For some reason it does not like solving the 3rd point. So it has to go to the 4th point, solve that, go back to the 3rd and try and solve it again, which it always does. So instead of solving 4 points, I end up having to solve 5, because only about 50% of the time does it solve that 3rd point for whatever reason. But then when it goes back to it, it solves it every time. Not sure why it doesn't like doing it the first time, but it doesn't. So now it'll go back to the 3rd point again. Now it should finish. Plate solved. Hey, look at that. Amazing. Okay, so now the alignment should be on again. And so now we should be able to send it to Dubé and actually have it on that star. And there we go. So let's move it more to the center. And that same error message again. Move it up to the middle a bit more. Come on, keep going. Here you go. Let's try centering this up, and then I will synchronize. Yeah, that's pretty close. Okay, so that should be right about on. I'm not sure why I'm getting this drift. Oh, now it doesn't seem to be drifting. Oh, maybe that just was. Okay, so now we should be able to synchronize on this. And then we were going to get what? 3180. So, NGC 3180. is right there, so it should be just a short hop over. Yeah. That's better. That's now moving in the right direction. Last time it just moved in some crazy direction. Okay. The little pinwheel. It should be right in here. I think this is it here. Let's try doing a plate solve. Well, I should, because it's right there. It's going to be right there. Let's do a plate solve anyway. I haven't done a plate solve yet tonight. Plate solving is very cool. It will tell me if I'm on it or not, and move the mount such that it centers the object. It's very cool technology. Solving frame, please wait. Doesn't seem to be liking to do it too much tonight. Too few stars. Okay, well, let's just kick the exposure up. I think it's over here. Yeah, this is it right here. Oh yeah, I was right the first time. It's right there. So I don't need to have... Let's bring it more to the middle. Yeah. Yeah, it's pretty close. Just a little bit more. That's probably about right there. Okay, let's start the image. Hey, Gary. Good to see you. I've definitely been having a Gary kind of night tonight. One thing after another. I just had to realign because for some reason my scope went crazy and decided that it completely forgot its alignment and went just in crazy directions for no apparent reason. So, I've had I've had software problems all night too, with everything just running really slow. But I think now I figured out what that is. Windows was updating in the background because I did not manually update Windows a couple of nights ago, right before my first session for this Dark of the Moon series, and as a result, Windows was trying to update in the background for the first hour or so of of the live stream. So fun. Oh yeah, look at that. That's a beauty. That's a beauty. Let's just zoom that big old bright blinding star out of the picture. That is certainly a very nice looking galaxy. Cool. Alright, so this is NGC 3180. Let's see what NGC 3180. NGC 3180. Spiral galaxy approximately 40 million light years away. Constellation Ursa Major. It has 2 hydrogen beta regions. Oh, so it actually has 2 hydrogen beta regions that are considered NGC numbers in and amongst themselves. 3180, 3181, 3184. Okay. Synchronize that while I'm here. Okay, so it has It houses a high abundance of heavy elements that was a magnitude, and a supernova in 1999 that was a Mag 14 Type 2 supernova detected on December 9th, 1999. And there have been other supernovas also discovered in it as well. So it's 40 million light years away. $40 million light years, so not really one of our most local guys, but not too far away either. Yeah, thanks, Gary. We did get some good stuff on Tuesday night. Of course, it's not too difficult when you're doing the low-hanging fruit like the stuff in Orion. That's some pretty spectacular stuff. I'm getting some streaky stars in here, so I think I'm going to reset the stack because it looks to me like the mount moved a little bit. So I think I'm going to... I've been having a little bit of drift going on tonight, even after I give it time to settle. So let's reset this and see if we don't get good. You see, even this is the stars are a little bit roundish, a little bit ovalish, I should say. So, not exactly the. But anyway, yes, so, you know, the stuff around Orion is the real low-hanging fruit. It's the easy stuff. But create some spectacular pictures, especially with that 533. The 533 is definitely a really nice camera. Lots of dynamic range, and just does a really great job, even with, you know, a low-end scope like my little reflector. So let's see how that does. Yeah, I just, for some reason, I'm getting some drift. If I look at the individual frames that come in, so this is the last sub-exposure that came in, you can see that the things are ovaling. For some reason, I'm getting some drift in the tracking is not seeming to be spot on tonight, so I'm getting a little bit of ovaling in the stars and a little bit of blurring of the objects. They aren't quite as sharp as they should be. So see what adding this third sub does. Didn't seem to do much, just darkening stuff. Oh well, we work with what we work with. This is why I don't do astrophotography, because it's just you gotta let it go at some point. You just gotta take it like it comes at some point. So it's not gonna be perfect. I don't have a $10,000 setup, so, but I still get some pretty nice images. So Curtis says star diffraction spikes look like there might be a focus or alignment. Yeah, I actually did just, well, both things have just been checked. In fact, I think just before you came on, Curtis, I thought the same thing about focus, so I went and to nice bright star and put the Batinov mask on, and the focus was dead on. So, and because I just lost my alignment a few minutes ago, I just redid my alignment, so I don't know. Everything should be pretty much spot on. But this is a really nice little spiral galaxy. It's almost like perfectly round. And the spirals are coming off wonderfully symmetrically. So, it's kind of a neat galaxy. However, I should stretch it a little bit harder so that you guys can see it a little bit better. Gotta make sure to pay attention to the what's on the live stream, because if I go by the way it looks on my screen, it's too dark for you guys. So brightening that up will let you see a bit more of it. It's a pretty one, though. Sure is a pretty one. $40 million light years away, I think it said. Yeah, 40 million light years. Lots of heavy elements, supernovae. Don't know that I've seen one like this so perfectly round. Usually they have some sort of ovaling or barred shape or something. This one's perfectly round. Yeah, you've turned into Gary's saying that he's been doing a lot of photometry. So yeah, you've turned into Mr. Photometry. I think the last imaging you were doing was when you were up here in Pahrump. Since then, haven't. Well, I guess you've done at least one live stream since you've gone home. You and Dave did one. But yeah, you've been kind of hiding in your own corner of the world doing photometry. Putting those courses to use. It's a pretty one. What is that star? I think that's one of the stars in... Oh, okay. It's one of the stars in Taurus. Oh no, that's still part of Ursa Major. No, it's just the bottom of the foot. Now we'll just go for another minute or so, and then we'll see what's next. 2392. Eskimo Planetarium. I think I'll skip that. Yeah, we'll go to the challenging ones, the Leo Quartet. Those are fun. Planetaries are better with the color camera. So Have I ever imaged... Frank asks if I've ever imaged M87. That's the one with the jet, right? Coming out of it. I don't think I have. I don't think I actually have done that one. Come on. Yeah, I don't think I have done M87. No. So maybe we'll tack that on at the end. That's a pretty one. Almost cloudy-ish. 3185. Alright, NGC 3185. Whoops. Why did that not go in there? NGC 3185. The Leo Quartet? Surprisingly enough. Regulus. Oh, and it's turned off my constellations. Okay. Alright, let's go see that one. So that one's a pretty one. That one's another nice one. Ollie put together a nice list for this this one. Okay, go deeper into Leo. Yeah. Yeah, well, definitely see them up there. Let's see. Yeah, so I think I actually want to bring that down a bit. I think I want to bring them down a bit more into the image, into the center of the frame here. And kind of back them up a little bit to the left. And I'm just getting a... I don't know, am I getting a tiny bit of drift? I'm just seeing a little bit of a drift. Yeah, probably fine. But I think that's why I'm getting a little of the ovaling, is because I'm just getting a little bit of a drift in the... For some reason the tracking is just drifting just a little bit. Okay, so the Leo Quartet. And this was a 3185? No. NGC... NGHC? No, NGC 3185. How far away are these? Yep. Spiral galaxy, 20 million parsecs away. of a 4-galaxy group called HGC 44. So let's just go look at that 4-galaxy group. Yeah, there's definitely, well, there's some interesting one in there too. Hickson 44 is a group of galaxies in the constellation Leo. Part of this group, yeah, so this is, well, anyway. There you go. Distance about 80 million light years, they're saying. So these are definitely not one of our local kind of things, but let's see how we're doing here. So we can bring this a little bit further that way. Darken it down just a little bit. But there's definitely 1, 2, 3, and 4 right in there. As we pull in more sub-exposures, we'll be able to oh yeah, there's another puff there. But the 4 brightest ones are here, here, and here. And isn't that an interesting looking barred spiral? Well, sort of. I don't even know if that is I don't know if you can call that a barred spiral. It's more of a barred swirl. That's pretty interesting. Huh. Just 4 very different looking galaxies. This one just looks like the regular lenticular soft blob. Lenticular meaning armless. Just sort of a blobby thing there. This one looking like almost an edge-on spiral or disk galaxy, where you've even got a dark dust lane right through this part of it here. You can see very clearly a dark dust lane in here around the edge. So this is very much a disk with a nice bright core. This one also looking like a sort of a spiral, but it's just perfectly round. It's like it got an inner core and then an outer band. And then this one, just a crazy barred galaxy that has, it's sort of, I guess, a barred swirly galaxy or something. Let's see if I can figure out which ones. Yeah, so which one is this? NGG 3187. Let's see if I can see anything specific about 3187. No, it does not have anything specific about it. No. Just a very interesting looking galaxy though. Pretty cool. This one here is also very interesting. Bright core and then a wheel around it. I don't know that I've actually ever imaged this before. Oh, hey, guy. Yeah, it's kind of late for you. Oh, you're in Montreal. Okay, yeah, you don't live far from where I grew up. Just a few hundred miles south in New Hampshire. So, good to see you. Thanks for showing up, and see you next time. Well, thankfully the internet seems to have stabilized here. Again, knock on wood. And now that Windows has apparently done updating, It computer seems to be running a lot more normally, so that's also good. I still don't, it's a mystery as to why I lost my alignment though. That was really weird. I'm using a DIY Ethernet dongle. I'm actually bypassing the Celestron Wi-Fi and connecting via the hand controller and all that sort of thing, and using an Ethernet-based Arduino dongle that was created by a guy who's an embedded systems engineer on cloudy nights, and it works really well. I have found it to be pretty much flawless, although tonight it seems to have completely, somehow, the alignment got lost. So that's pretty weird. I don't know that the dongle had anything to do with it, but one of the things that the dongle does, aside from allowing communication between my computer and the mount, is it also turns off the Wi-Fi, the internal Wi-Fi on the Evolution, which I'm not using because I'm connecting via the Ethernet cable. And the interesting thing that happened was, when it lost the alignment, the Wi-Fi, the internal Wi-Fi light came back on. Almost as if the mount somehow reset itself. I don't know. Very weird. I'm just going to chalk it up to some sort of fluke, because did a 2-hour live stream on Tuesday night and nothing like that happened, so not really sure what the heck happened there. But something definitely got goofy. CPWI actually thought it was still pointed in the right place, so it seems that the mount itself is what hiccuped. Oh well, power cycle, realign with StarSense, and back on the road. Luckily it's luckily, thanks to the StarSense, the alignment only just takes a couple of minutes and is fully automated, so not such a big deal. EAA is a great game of whack-a-mole, Gary says. Yes, that is certainly one way to look at it. There's doing these EAA live streams is a melting pot of many different disciplines. Not only astronomy geekiness and equipment and everything, and understanding that and how it all works, but then the incorporation of computers and all the software that goes with them, and networking, and other forms of connectivity, USB connectivity, etc., etc. And that's just for the imaging. And then to add on the live streaming, it's another whole discipline of broadcasting software and understanding how to connect into YouTube and to make it all happen. It's you have to wear many hats when you do this, and it's a lot of moving parts. When everything works, it's it's enough to juggle even when everything works. But then you start having one of the spinning plates you're trying to keep over your head starts going out of whack, and it can get out of control pretty quickly. Lots of different disciplines and pieces of technology have to show up together to make all this happen, and you're just sitting there trying to spin all these plates. So there's 10 minutes on the Leo Quartet. That's pretty cool. That's a very interesting and disparate collection of galaxies. And there's certainly other ones in here too. There's a nice fuzzy patch there. There's another fuzzy patch there. That looks like possibly one up there. Anyway, but once you get into this region, like I said earlier, this whole region, Leo and the Big Dipper, this whole area in here is just rich. It's just lousy with galaxies, which is why over the next 2 or 3 months, as this stuff rises higher and higher in the sky each month, we call it galaxy season. So, very cool. Okay, what's next there, dear Ollie? M94, the Croc's Eye. Okay, M94, the Croc's Eye. Back toward the Big Dipper. Alright. Let's... Next target. This one will probably show up pretty readily. If I recall right, it's a pretty bright one, yep. So we'll just, well, let the scope settle out for a minute here. Try to put it back in the middle a little bit. Give it a few seconds to settle. Scope. The mount is seeming to need a little more time to settle tonight than normal. Alright. So this is going to be M94, the Croc's Eye. Let's see what Stellarium has to say about it. Yeah, kind of a nice one. Sort of like that one we saw before. Distance... Oh, this one's only 16 or so million light years away. So this is a much closer, much smaller guy. And we're at an orientation of 85 degrees, so we're almost dead on looking down at the top of it. So that's pretty cool. M94. Let's see what Wikipedia has anything else interesting on it. As a spiral galaxy in the mid-northern constellation of Canis of Venatici. It was discovered by Pierre Marchand again. Our old friend Pierre. Let's move this stuff to where it makes a little more sense. Oh yeah, but you can already see the faint dust around it. This is interesting. Cataloged by Charles Messier 2 days later. Although some references describe M94 as a barred spiral, the bar structure appears to be more oval-shaped. The galaxy has 2 ring structures. Yeah, you got a bright inner one, and then there's a much fainter one on the outside here, which you guys may not be able to see so well. I'm going to push the stretch a little bit more so that you can see it better, at the risk of the image being a bit noisy. But hopefully you guys can see that there's almost like a cloud, a cloudy ring around it. M94 is classified as having a low ionization nuclear emission region. Nucleus. Low ionization nuclear emission region. These kind of galaxies in general are characterized by optical spectra that reveal that ionized gas is present, but the gas is only weakly ionized. The atoms are missing relatively few electrons. M94 has an inner ring with a diameter of about 70 arc seconds, given its distance about 5,400 light years, and an outer ring with a diameter of... Wait a minute. M94 has an inner ring with a diameter of 70 arc seconds, given its distance about 5,400 light years, and an outer ring with a diameter of 600. 5,400, how can it can't be 5,400 light years away. And has an outer ring. Oh, okay. An inner ring with a diameter of about 5,400 light years, and an outer ring with a diameter of about 45,000 light years, or a little less than half the size of the Milky Way. So the outer part here is about 45,000 light years across. The Milky Way is about 100,000 or so, maybe a little more. Some people estimate it as 120. But so it's somewhere about 40% or so the size of the Milky Way is what the outer structure is. See if I can brighten it up just a little bit. Push that stretch a little bit more. The inner ring is the site of strong star formation and is sometimes referred to as a starburst ring. The star formation is fueled by gas driven dynamically into the ring by the inner oval-shaped bar-like structure. See a bit of an ovaling, but not really a bar. A 2009 study conducted by an international team of astrophysicists revealed that the outer ring of M94 is not a closed stellar ring, as historically attributed in the literature, but a complex structure of spiral arms when viewed in mid-IR and ultraviolet. The study found that the outer disk of this galaxy is active. It contains approximately 23% of the galaxy's total stellar mass and contributes about 10% of the galaxy's new stars. In fact, the star formation rate of the outer disk is approximately 2 times greater than the inner disk, because it is more efficient per unit of stellar mass. There are several possible external events that could have led to the origin of M94's outer disk, including the accretion of a satellite galaxy or the gravitational interaction with a nearby star system. However, further research found problems with each of these scenarios. Therefore, the report concludes that the inner disk of M94 is an oval distortion which led to the creation of this galaxy's peripheral disk. The inner disk of M94 is an oval distortion which led to the creation of this galaxy's peripheral disk. Okay. Not really sure what that means. An inner distortion. Don't know. Definitely a faint little cloud there. Definitely something in there. Push the stretch a bit more. Really stretching the crap out of this one. But it does allow it to be seen better. almost like three distinct zones. The very bright core or nucleus, which has a fairly sharp outer boundary, and then the bright intersection that's outside of that, and then the third section, which is the outer cloud. Croc's Eye, right? That's what it's called? Croc's Eye Galaxy. Well, I can see why Charles Messier thought this might have been a comet. Certainly a bright sucker. And big, too. I mean, that's you know, this is a 1 degree field of view, and that's a pretty good size object. But it's pretty close to us, so. About to come up on our 10th minute of data. That's about what I like to give it, about 10 minutes. They do. Galaxies are a bit like snowflakes. You look at them real quick, they all look the same, but you start really looking at them, they're all very, very different. And there's billions of them. So, cool. Well, M94 Croc's Eye. That's a good one. Okay, 3227. Oh, this is the whirlpool look-alike. Okay, 3227. NGC. 3227. Doink. Where are we at? 54 degrees. So we're turning to the, yeah, we're turning right to Leo, even further. Yeah, cool. Alright. Let's go check that guy out. Next target. Boy, everything's running nice and fast now that the Windows has stopped frickin' updating. Okay, what are we looking at here? Oh, I don't have an image? Well, I definitely see something in here. I'm going to assume that that's it. So let's move it a bit more into the middle. Yes, thank you. And down a titch. And down a titch more. Yeah, actually there might even be something in here too. Alright, let's fire that up. See what we get for this. And then after this, we will try and see if I can find M87. I don't think I have ever imaged M87. But Frank said M87, so we'll see if we can see the jet. I want to see first, though, when this comes up, what how well centered it's going to be. And I'll resynchronize Stellarium. that one was pretty streaky, so obviously the mount had not finished moving. So reset that one. Mount had not quite settled. Gary says, it's funny, it's almost impossible for me to do the observing challenge due to the poor outlook from home. Probably one of the reasons I got into photometry. The poor outlook, meaning your line of sight, you have a pretty limited, where you can see is pretty limited. I, on the other hand, have a pretty open view. So, I can usually do most everything. I mean, pretty much anything 30 degrees and above. In most directions, I pretty much have it. So, but you know, out here in the middle of the desert, don't have a bunch of trees, so not a whole lot of things out here to obstruct my view. Really, out here, it's just structures that do my obstruction. So, you look at objects within 10 degrees of Polaris. My only real clear outlook where I can get 4 to 6 hours of imaging. Oh yeah, for that amount of imaging, yeah. I guess that would be true. Yeah, well, that's, you know, you live in a much more lush part of the world than I do. Beautiful San Diego. You know. But you get a lot of trees there. Out here, no such... we have trees out here. They're salt cedars mostly, which are an invasive species. But they usually don't grow too big. And they're more pests than anything else. Their roots really kind of screw things up, so we tend to try and not let them get too big anyway. So yes, a pair of interacting galaxies here. What do we got? 3227. Let's see what NGC 3227. NGC 3227. An intermediate spiral galaxy that is interacting with the dwarf elliptical galaxy, NGC 3226. So the bottom one is the spiral, and the upper one is the dwarf. The two galaxies are one of several examples of a spiral with a dwarf elliptical companion that are listed in the Atlas of Peculiar Galaxies. Both galaxies may be found in the constellation Leo. William Herschel already recognized them as a double nebula, and they were jointly listed as Holm 187 in the catalog of double and multiple galaxies, and as ARP94 in the Atlas of Peculiar Galaxies. Amateur telescopes can discern them, but require magnification of about 100 times. They are situated approximately 50 arc-minutes east of the well-known double star system Gamma Leonis. So the spiral, they're saying, contains a supermassive black hole at its core, too. Has a lot of X-rays coming out of it, blah, blah, blah. Yep. So, a barred spiral and a dwarf galaxy getting it on here. You can also see up here there's definitely a little puffy smudge up there, so there's definitely something happening there. A couple of galaxy, or a galaxy definitely up there. That's not a star. Yeah, but once again we're in Leo, so all kinds of good stuff here. Galaxy season is a-comin'. Let's see, we're about lined up, so let's center that. And let's see. Frank is talking about M87. Let's see where it is in my sky here. Ooh, it's a little low. It hasn't quite risen. Yeah, it's almost dead east, and it's not even 30 degrees. So I may not be able to see that for a while. Yeah, it's well below Leo. Where are you? Yeah, so I might be able to get that. I might be able to get that. So we'll give this, we'll give these two here a good few minutes, and then I think it's probably just cleared my shed. Generally, I need to stay over 30 degrees east and west. North and south I can go lower, but east and west I've got basically built structures that keep me above 30 degrees, but I think I'll be able to get this. Especially now because my new wedge is bigger than the old one, so my scope actually sits higher. Okay, good night, Gary. Thanks for stopping by. Appreciate you being here. And yeah, so far, well, as the evening has gone on, it's gotten smoother and smoother. Although I'm starting to get cold and hungry, so after I do this and we do M87, that'll probably be the last thing. So, but it'll be interesting to see if I can see the jet. So I don't believe I have ever attempted to image the M87 before, but it's possible I did. But anyway, good to see you, my friend. Have a good evening. Enjoy your photometry and whatever else is going on this evening. Yeah, I guess you said you were on a second computer crunching your photometry stuff, crunching your data. Starting to get some interesting structure on these two galaxies. The barred spiral definitely has some interesting stuff going on there. Let's stretch it a bit more too so you guys can see it a little better. Kind of brighten it up. Kind of brighten it up a little bit more. Oh yeah, with the 533? Yeah, mono cameras in general do better on galaxies than they do than the color cameras. They're just plain more sensitive, and there's not a whole lot of color to see anyway, so they tend to do better. Although the 533 has bigger pixels than the 183, so which makes the 533 more sensitive. So it's a little bit of a trade-off. But yeah, the 183 does. The mono cameras tend to do pretty well with galaxies. Interesting little. There's sort of a puff of stars out here and out here. Where these two are interacting, and the fur is flying, I guess you could say. Throwing off various random stars. And we'll give this one more minute. We'll go to 12 minutes on these, if for nothing else, to give M87 another minute or two to rise a little bit higher. I think I'll be able to see it. But yes, the wedge, this new wedge is a lot taller than the old one, than what the old one was. So this is sitting easily a good 5 or 6 inches higher than it did on the last one. So this shed basically is really close, and so this is my biggest obstruction, is being able to actually see over the peak of this shed that's right behind you, which is that's east. And so that's where Leo is rising right now. So because the wedge is so much bigger and taller, hopefully it should be able to, I think I should be able to clear it enough to see that, but we'll see. But there's 12 minutes. There is 12 minutes. On, what was it, 32:27. There's 12 minutes on 32:27. So let's head down and see if we can see M87. Yep, okay, well, it looks like it is going to clear. Yeah, actually clears it by quite a bit. So that must be it right there. Let's see, notice how it's all marching to the right. So I've got to give the mount a few seconds to settle out, because it's just every frame is marching to the right and marching to the right. There we go. I think that's kind of... I don't know, is it? I think that's kind of settled in. Alright. Let's see if we can see a jet. M87. Let's look it up here. CA 87, also known as Virgo A, is a supergiant. It's a supergiant elliptical galaxy with about 1 trillion stars. Whoa! 1 trillion stars. It's a supergiant elliptical. One of the most massive galaxies in the local universe. It has a large population of globular clusters, about 12,000, compared with the 150 to 200 orbiting the Milky Way, and a jet of energetic plasma that originates at the core and extends at least 1,500 parsecs, or about 5,000 light years, traveling at a relativistic speed. Okay, there's our first view of it there. Let's... Yeah, we'll see. Yeah, see, but it's still, the stars are still streaked, so I'm gonna reset this because the mount had not. It's one of the brightest radio sources in the sky and a popular target for both amateur and professional astronomers. Huh. Charles Messier discovered it in 1781 and cataloged it as a nebula. Let's clear you and start over again. Cataloged it as a nebula. It's about 53 million light years from Earth and is the second brightest galaxy within the Northern Virgo cluster, having many satellite galaxies. Unlike a disc-shaped spiral, M87 has no distinctive dust lanes. Instead, it has an almost featureless ellipsoidal shape typical of most giant elliptical galaxies, diminishing in luminosity with distance from the center. Forming around 1/6 of its mass, M87's stars have a nearly spherical symmetric distribution. Their population density decreases with increasing distance from the core. It has an active supermassive black hole at its core, which forms the primary component of an active galactic nucleus. The black hole was imaged during data collection in 2017 by the Event Horizon Telescope, with a final processed image released on 10 April 2019. It's a strong radio wave emitter. Its galactic envelope extends to a core of a radius of about 500,000 light years. Extends to a radius of 500,000 light years, where it is truncated possibly by an encounter with another galaxy. So it has a radius of about 500,000 light years, which means its total diameter is probably somewhere around 8 to 10 times the size of the Milky Way. Not seeing a whole lot in the way of a jet, though. Seeing a couple of stars down here. But I'm not seeing the jet. See, I'm seeing a couple of stars here, but coming out at 3 o'clock, huh? Huh. I am not seeing what you're seeing. But more sub-exposures will probably help. Definitely a lot of galaxies in this image, though. These are not stars. That's not a star. This isn't a star. That's a nice little spiral or barred something. Yeah, I'm not really seeing it much at all. Definitely on the right target. That is definitely it. But I am not seeing, even in the Stellarium picture, and I'm seeing these two stars here that seem to have some nebulosity or something associated with them, but even in their image I'm not seeing the jet. So I'm not sure even which direction it comes off. Now if I look at, there is a picture of it in Stellarium, or I'm sorry, in Wikipedia, but I'm not really able to match up not really able to match up the what direction it is even coming out in. So the pictures are just they're so different. I mean, basically I'm looking at a Hubble image on Wikipedia, and it's really hard to compare it to mine, since these stars in mine are the size of dinner plates compared to the very fine sharp points in the Hubble image. So it's hard for me to match up what's going on there. Almost makes me think I'm on the wrong galaxy, but no, it looks right. These stars definitely match up. So shorter exposures with higher gain. Okay. We can definitely try that. Let's drop to let's see, let's drop to a 16-second exposure. Let's try a 16-second exposure. And a gain of 400. Now, I'm not going to have a dark for this. Criminy, yeah, I'm not going to have a dark for this. So this could definitely be wacky. But we'll see what happens. It's probably going to be pretty noisy and ugly, because I don't think I even have any darks. Oh, yeah. Well, yeah, I don't have any darks for these settings. I definitely do not. So let's see if anything interesting comes out of that. Stretch the heck out of it. Yeah, still not seeing much of anything in the way of a jet. It's possible that because it is still fairly low on my horizon, that I just don't have sufficient contrast to see it yet. And in April and May, as it continues to get higher and higher toward the meridian, hopefully I'll be able to pick up some more contrasty images of it, because I'm not seeing it. Let's try going again. 450, 8 seconds. See what that does. Let's see what that does. Let's see how the histogram probably still going to need to be marched to the right. Not too bad. Just stretch the crap out of it. See, and again, I get the 2 stars down here, but I'm not seeing any jet. I'm not seeing any jet on there. Oh, you're welcome, Frank. Thanks for suggesting it. It is an object that I'm interested in, so I definitely do want to be able to image it. I definitely do want to be able to image it, but tonight it's not happening. So, and I don't believe I've ever tried to image it before, so yeah, and again, I think being low on the horizon like it is tonight, I think the contrast might just not be enough yet to be able to pick it off. So we'll try again next month or in May. By May it should certainly be almost dead overhead. So we'll take a look at it again. But I'm not seeing it tonight. So it looks like it's probably going to be a bust tonight. In any event, I've been up for almost 3 hours here, so I think I am going to call it a night and go in and get me a little something to snack on, because I'm getting hungry and cold. But thank you everyone for being here. Turned into a pretty nice night after a little bit of a rocky start, but things seem to have turned around in the end. And thanks everybody for being here. Looking like the weather is going to be a little not agreeable for a bit, so may not be back for a few days, but hopefully we'll get at least another couple sessions in before the moon returns. But we'll see you then. In the meantime, have a good night, everybody, and I will see you next time. Thanks, and good night.